Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Okay, so we are now in lecture 3 or 4, the second last final part of our lecture for this topic, with the subtopic of 10.3 normal distribution. Okay, so for normal, last time we discussed about binomial and Poisson, but which both are distribution for normal, we call discrete random variables then. So for normal is for continuous. Okay. So then identify the normal, determine the mean and variance, and all these in the solve related problem. Okay. So last time for binomial and Poisson is a discrete situation, and for normal is continuous. Okay. So normal distribution, this is what we call normal probability distribution is a bell-shaped curve. Okay. So if you imagine this, it's just like we call a bell, old bell that we call shape. That sometimes if you can see in we call in some movies, they recalling that we call the bell in the church, or we call an old stuff that. Okay, and this is a shape. The total area under the curve is 1.0, and the curve is symmetric about the mean. Okay, so there's a mean here, middle here, and it's symmetrical, which means that this we call the shape on the left equal to the shape on the right side, and has a random variable which is similar, we call continuous, and this is the we call the parameter x normally distributed with the mean parameter of mean and variance. So then standard normal, the normal distribution with a mean equal to 0 and standard deviation is called the standard normal deviation, which I think the standard deviation is to be sigma only. Okay, never mind. To change x in normal distribution into z of in standard normal distribution, use the transformation formula. So from x normally distributed with the parameter of mean and variance, we turn into the z of standard normal distribution. Standard we call, as you see, or we call the definition of every single label that we have here, the mean of x, the population, and standard deviation. Okay. Okay, now from x normally distributed, for this one here, we turn into the z standard normal normal distribution. And you can see that. Okay, never mind. How to use the standard normal tables? Use the symmetrical properties of graph to find the probability from the tables then. Okay. So each of this we call area on left side are equal to the area on the other side. As I mentioned just now, the total area between the curve and x-axis are equal to 1. And it is we call symmetrical with a mean equal to 0. So we divide the area on left side is half, which is 0.5. And on the other side is also 0.5. Okay, so symmetrical on left side for z less than negative a. So we just imagine that if we fold this, okay, let's say if we bring this, or we call this area with the we call the red dot on the other side here, equal to the area of this. Okay. Okay, read the probability from the table with Z equal to A. The standard normal table shows the probability for upper end area, which is Z greater than or equal to a small letter of Z. Okay, so which I think that for at this moment we look at the definition first. When it comes to the example, it makes our make it clear that. Okay. For this one here, this is a value of A that we refer again in this statistical book, okay, to find the value of each of them. Okay, so if this is the one, Z is greater than negative A. So this is we call the middle of the curve, and is greater than this one here. Okay, so this is not the area that we wanted. So it is the whole area. Okay, the whole area on the left plus on the right side is equal to 1. But then this probability of X, the Z greater than negative A. So the whole area minus the area on left side. So the area on left side we consider as this one here. So the whole area, which is equal to 1, minus the area which is less than negative A, we call the one that we call the shape with the blue ink, okay, equal to the area of this part here now. So 1 minus probability of Z greater than A. So just imagine that if I bring this red dots area to the left side, and yet this area is equal to this area. They are equal. Okay, so we use this. We call this calculation that. There you go. So this area equal to this area. Okay. Then next, we call the area between negative B and negative A. So if we bring this to the other side, there you go. Okay, it is probability of Z greater than A. Okay, if I just imagine this, to imagining this one here, okay. So then for the first property of Z greater than A, just imagine that there's A here, A, okay, and minus property of Z greater than B. Just imagine that there's a B here. So we call probability of Z greater than A, the whole area from A to the right side, minus probability of Z greater than B on the other side here. So what's left is area between A and B. Okay. So then equal to this one here. So we continue. Okay, so now probability of we call Z between negative A. Negative A means it gonna be okay. Negative A somewhere around here on left side. to 0. Okay, we'll see. This one here now. Okay, from negative a to 0 equal to, okay, bring this to the other side. There you go. Okay, so it is property of z greater than 0. Property of z greater than 0 means that the whole area on right side, okay, 0.5, minus property of z greater than a, this part here. So this one left hand, it is 0.5 minus property of z greater than a. Okay, so then now is from negative a to a. So just imagine that this is a middle, okay, mean equal to 0. So there is a negative a here and also a. So guys and girls, just imagine that if half of this is between negative a to 0, and another half here which is from 0 to a, actually that these two area from left hand side of this middle, we call the middle line, is equal, right? So that's why we come up with 1, the whole area equal to 1 minus double 2 times of property of z greater than a. Okay. Okay, let me explain this. Let's say I took we call the area on the left side and another half on the other side. Okay, so the first one here, okay, I take the half of this a, okay, plus with this part here, also a, this is negative a and a. Okay, the whole area of this is 0.5. Okay, and whole area of this half is also 0.5. This area is equal to this area. They are equal. Okay, so the whole area which is equal to 1. So if I come up with this one here, let's say, okay, let's say on the first part of this, I make this one as a 0.5 minus property of z greater than a. Okay, and on this side is also another of 0.5 minus, even though it's negative a, just imagine that this area, okay, this area is equal to this area. So I just come up with another property of z greater than a. Okay, 0.5 plus 0.5 equal to 1. And then negative property of z greater than a plus minus another of this is minus 2 property of z greater than a. There you go. Then you get this one here. Okay. Example 1. If z is binomially distributed with 0.1, 0 with the mean and the variance, find the property of following of all this. Okay. Okay, so the first one then, property of z greater than or equal to 2.5. Okay, whether greater than or greater than equal, okay, never mind. This is still what we call as equal because this is for continuous. Okay, so how are we going to find answers using this book? Okay, now the first one here, to all my students, please turn to page 21. Page 21. Okay, now this is 2.5. So we refer to the value of z, and scroll down until you find it is 2.5. Okay, 2.5, and then 2.5, according to how we read this book, is a 2.5 plus with 0, 0, 0. Because 2.5 plus 0, 0, 0 is 2.5. Okay, so 2.5 here, and then refer to 0, 0, 0. Then you get 2.5. We call intercept with a 0, 0, 0 here. It gives you 0.0026. Okay, so this is 0.00621. Okay, then the next one for B, probability of Z greater than 0.6. Okay, for this one here now, it is okay, just let's say this is the bell-shaped graph. Okay, so look at the question here. Make a mistake that is a Z greater than negative 0.6. So just imagine that it's a negative 0.6 here, and it is greater than. Okay, so the whole area from negative to positive infinity, the whole area is equal to 1 minus, okay, the whole area minus the area on the left side of this. Okay, the area without the line of the blue line here. Okay, so probability of Z less than equal to negative 0.6. Okay, now look at this one here. What if I turn what we call the area on left side to the left right, and this one to the left side? Okay, so negative 0.6 is what I bring up here, 0.6. And this area, we turn it here. Are they equal? Yes, they are. Okay, so then we try to find the area on the right side which is equal to this side, because from this statistical book they only give you the we call the probability which is greater than or equal only. Okay, so then it is 1 minus probability of Z greater than or equal to negative 0.6. Okay, so then okay, from here to here, 1 minus probability of negative, wait, this one should be positive. Okay, according to the value of 0.6 here. Okay, 0.6, again, from this statistical book, look at the Z to 0.6. Okay, Z to 0.6 plus with 0, 0, 0. And you get negative 0.2743. Okay, again, Z equal to 0.6 plus with 0, 0, 0, which is intercept with 0.6, and it is negative 0.2743. Okay, negative 0.2743. 0.2743, and it is equal to 0.7257. Okay, let's go move to the question C. Question C, the probability of negative 2.23 Z less than negative 1.23. Okay, this one we can refer to this graph. Okay, this is the middle line. Now, negative 2.23 okay, and then negative 1.23. So this is the area, okay, on left side. And now we turn it into probability of Z, which is lies in between 1.23 and 2.23. Okay, so just imagine that this area we bring to the other side of this, on the left side. And the first one then, this, okay, 1.23, we bring on the side because this is 1.23, and this one here for 2.23. Okay. So then, this is probability of Z, okay, greater than 1.23, okay, greater than 1.23 minus probability of Z greater than 2.23. Okay, so 1.23, okay, from this table book, 1.2 from Z. So find out where is 1.2 here. 1.2 plus 0.03. Okay, how we read this? Find in the Z of 1.2, and then look at the, go on the numbers, the value on the top here. Okay, so 1.2 plus 0.03, so 0.03. Okay, so 1.2 plus with 0.03, it is 0.10, is it a, or 1.1093. Okay, 1.1093 minus 2.23, which means that is 2.2 plus 0.03. Okay, so 2 plus 2.2. Okay, 2.2, and then 0.01, 0.00, 0.01, 0.02, 0.03, 0.00, 0.0129. Okay, so it is 0.0129. It is equal to 0.0954. Okay, you may test the answers here. Okay, 1.1093 minus 0.0123. Class, I'm sorry. Probability cannot be greater than 1. Sorry. Okay, miswriting that. Okay, 0.1093 minus 0.0123. That's not it. 129. That make a mistake there. Okay, 0.1093 minus 0.0129. 0.1093 minus 0.0129. Okay, 0.095464, something like that. Okay, is it 95464? Might be 6. Okay, you can by yourself that. Okay, and then for the probability of modulus of z greater than 1.2, which means that it is probability of z for this one here. You still remember this? If I come up with term of x, modulus of x greater than a, where we define it is a two ways here, which is x greater than or x greater than a, okay, and also or x less than negative a. Okay, so that's the way we write it here now, which is z greater than 1.2, okay, and plus with probability of z less than negative 1.2. Okay. And now okay, so I'm sorry because the surface of this board, okay, may give me a problem to sketch it nicely here. Okay. So then the first one here, z greater than 1.2. Okay, 1.2, and it is here. Plus probability of z less than negative 1.2. Okay, so class, actually that this area is equal to this area, meaning we count this twice. Okay, so what can we do here now is the whole area between the curve and x-axis are equal to 1. Okay. Okay, class, if I use this minus 2 probability of z greater than 1.2, meaning I'm looking at an area, I'm finding an area, we call area of this. But this is not the area that we're looking for. So it means that I make a mistake here now. So the correct answer of the correct way of solving this is we just count this and this by double the probability of z greater than or equal to 1.2. This area is equal to this area. So why don't we just find out the area of this part and multiply with 2. Multiply by 2. So then it is 2. Okay, Z, probability of Z greater than 1.2 again. Okay, 1.2, Z from 1.2, 0. Okay, 1.2 for this part here, according to this, is 1.2 plus 0.00 equal to 1.2. So 1.2, okay, 1.2 plus with 0.00, it gives you 0.1151. 0.1151. So 0.1151 multiplied with 2 equal to 0.2302. Example 2. Okay, so for this one here now. Okay, so class, the way we solve this is differently from the previous. Okay, let's say the first one then. For A, probability of Z greater than A equal to 0.6217. Okay, class. Okay, we refer to the previous notes. As I mentioned just now. Okay. Where half of this area is 0.5. Half of this is 0.5. And half of this is also 0.5. So 0.5 plus 0.5, which is equal to 1. Okay, so the probability of this is 0.6, which is 0.6 is greater than 0.5. Which means that this we call this probability is we call across the border, means that it's a 0.5 plus with part of the probability on the left side. Okay, so half of this. So class, it is A, where A for this answers here is on left side, where A is less than 0. Okay, meaning 0.5 plus with the probability here, then 0.5 plus here equal to 0.6217. Just imagine that this is 0.5 and this part here is 0.1217. 0.1217 plus 0.5 is 0.6217. Okay, the point is now here is, what is the value of A? Okay, so the whole area between the curve and x-axis equal to 1. So 1 minus this area. 1 minus probability of Z less than A equal to 0.6217. Okay, and then negative probability of Z less than A equal to 0.6217. 1 bring up here. Okay, minus 1 equal to 0.6217 minus 1 equal to negative 0.3783. Multiply with negative left and right. Okay, so now we are going to find out, okay, probability of Z greater than A. What if this area we transfer into on right side on left side here, we bring to the other side, on right side. Okay, so this one here now, we imagine that this A, we bring up to the other side, and we find that the area here, okay, equal to probability of Z greater than or equal to A. Okay, so even though this A is negative, but because we bring it to the side, so we need to label this one A as a negative. Even though this value is positive, but because we label this positive on the left side, A is negative, so on this side here, it becomes negative A. Okay, negative A. So then, probability of Z greater than or equal to A, 0.0378. So let's find out. Okay, meaning, the way we solve this answer is different from the previous because we are not referring to the value of Z and this value. We are going to find the value of 0.3783 inside the table. Inside here. Okay, we're going to find the value inside here. So 0.3783, 0.3783. Class, I found it here. Okay, 0.3783, where it is intersect, we call middle between 0.3 and 0.01. 0.783, 0.3783. Okay, on the left side is 0.3, on the top is 0.01. Meaning, it is 0.31. Okay, the value of A, negative A, is 0.31. Okay, so meaning the value of A originally here is A equal to negative 0.31. That's it. A is negative 0.31. Okay. And next, probability of modulus of Z less than A equal to 0.8472. Okay. So from here, it is probability of Z in between A, negative A, and A is 0.8472. Okay, so class, if this is the normal curve, okay, so it is from negative A to A. From negative A to A. So if I imagine that we concentrate on this part only, Why? Because this area is equal to this area, half and half. We just add these two, or double, or we multiply. Okay, find the area on this side and multiply with 2, and we get the whole area of this. Okay. So what can we do now? For this one here, find this area and multiply with 2. So 1 minus 2 times probability of Z greater than or equal to 0.8472. So then, bring this one to the left side, minus 1, and negative 2, probability of Z greater than or equal to A equal to, okay, again, your calculator, 0.8472 minus 1. It is 0.8472 Okay, this is negative 0.1528. Okay, multiply with negative, left and right. Then property of z greater than a equal to 0.1528 divided by 2. Okay, it is 0.0764. Okay, so from the table, we need to find out 0.0764. 0.0764. I found it here. Okay. 0.0764, where it is between 1.4 and 0.03, meaning it is A equal to 1.43. Okay, again 0.0764. Okay, is between 1.4 plus 0.03. There you go. There you go. Okay, now example 3. The random variable x has normal distribution with mean 10 and standard deviation of 2. So find this one here. Okay. So x has a binomial, normally distributed, not binomial. It's a normal then. Sorry. Okay, with a mean of 10 and variance. Variance is 4. Okay, variance equal to 4. And given here standard deviation equal to 2. Okay, so we transform this into z standard deviation of this, which is equal to x minus mean divided by standard deviation. Okay. Okay, so for the first one here, A equal to property of x greater than 13, which is equal to property of z to standard normal distribution here, which is 13 minus mean divided by standard deviation, which is 2. Okay, so finally we calculate for this value here. Okay, 13 minus 10 divided by 2. Okay, 13 minus 10 divided by 2 equal to 1.5. Okay, so then it is 1.5 here, property of z greater than 1.5, and 1.5 strictly from this statistical book. Okay, for 1.5 means that we find out 1.5 plus 0.00. 1.5 plus 0.00. Okay, 1.5 with 0.00 is 0.0668. Okay. This is 0.0668. Okay. And then for question B, probability of x from 9 until 13. So we transform into this, we call the standard normal distribution of z from 9. 9 minus 10 divided by 2, and also 13 minus 10 divided by 2. Okay, so using a calculator here, this is z that lies in between negative 0.5, and here is 1.5. Okay, so for this case and for this case, so first one here is negative 0.5, negative 0.5, and 1.5. Okay, class. The whole area is equal to 1 minus, just imagine that if between these two, I separate into two parts. The first one the first one is for 0.5. 0.5. Okay. And then another one here is 1.5. Okay. So addition of these two is just like we multiply 1 minus probability of z greater than 0.5, okay, and minus probability of z greater than 1.5. So then, for this one, z greater than 0.5, find it from here, 0.5 and 0, which is 0.3085. Okay, it is 0.3085 minus the next one here, 1.5, okay, 1.5, and 0 is 0.0668, okay, equal 0.0668, and the total of this equal to 0.6247. Okay. So class, for the next example, which I think that I let all of you to try. Okay, so the previous example is where, okay, is how we find the solution using this statistical book. Okay, and here is where we apply all the accelerated examples that we did just now into the situation of this. The height of matriculation student can be normally distributed with 10, 170, and standard deviation of 5. So, what is the probability that a student selected at random has a height between 174 and 178? So class, I give you a clue for this, where this is X normally distributed with parameter of mean is 170 and standard deviation equal to 5. So variance is 5 square or 25. So for this one here, which is Z 174, 178, which is 174 minus 170 divided by standard deviation equal to 5, and this is 178 minus 170 divided by standard deviation equal to 5. Okay, so for this one here, it gives you 0.8 and 1.6. So find the answers of this, okay, value of this and value of this. Okay, both of these are positive, meaning, okay, this is a mean which is 0, so 0.8 might be somewhere around here, and 1.6 somewhere around here. So this is the area. Okay, so I do hope you can all of you can imply all the method that I showed you just now, example 1, example 2, and example 3. okay, to solve this application of question here. Okay, so then out of group of 150 of these matriculation students here, how many would be expected to have a height less than 164? Okay. Okay, so I just give you the rough circle calculation of solution of this. So again, it is probability of x less than 164 which is equal to probability of z, okay, 164 minus 170 divided by 5. Okay, so it is probability of z less than negative 1.2. Okay, and for this one here, it gives you 0.1151. Okay, back to the question here. Out of 150 matriculation students, how many would be expected to have a height less than 164? So to answer this, it is 150 multiplied with 0.1151. Then it is equal to 17.265, or we round up it to 17. Okay, 17 students that height less than 164. So this is the flow of the story. So you count up by yourself here. You might write down out of 150 matriculation students, okay, and expected to have height less than 164 equal to 150 multiplied with the value of this, and you get 17. Okay, so this is an exercise for you to try, and try yourself. Try it first. If you haven't tried, then you don't know whether you can solve it or not. Okay, so that's all for today. I do hope that this video helps you. Okay, that's all. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.